Okay, everybody. Let me just check. Make sure we haven't gotten any nasty email messages about why someone can't get in. Good. Looks like people are joining. All right. So we're just about ready to get started for today. We're going to try and fit a couple things in. We may not get through all of them, and if that's the case, we'll just continue on wherever we left off the next time. So first up to bat is Wing, who had some questions about some 4-axis horizontal programming. So we're going to take a look at his part. After that, we had some questions from Mike about setting up a post for his style of machine, and he gave me some answers, and so we'll take a look at that, but that'll be the second thing up. I did get something from Steven about a G68.2 issue, and I'll be happy to tackle that next. So basically, office hours is first come, first serve. You know, people put in their requests for help with whatever their topic issue is, and I go through them as quick as I can, and you know, we work through it and discuss it and try to figure out the best approach. So with Wing's situation, he's got a 4-axis horizontal, and let me get the levels out over here. And this is what we're trying to do. So we've got like a round cylinder, probably steel, with some kind of cam groove in it. And one of the first things I did was took some slices on the part. And the reason I did that is to try and get an idea if this wall is truly flat. In other words, can we actually produce this on a 4-axis machine? The limitation of the machine is that it is a 4-axis machine. We are not able to tilt the tool perpendicular to the axis of rotation. So, and typically when we cut a shape like this, because it's a 4-axis machine, we're kind of limited. I mean, we can enter and exit the cut, but usually you want to try and stay on centerline when you're making the cut. Some paths will let you go off centerline, and that would be, let me move the levels out of the way there. So when we look at our toolpaths menu for 4 and 5 axis, I know they're big on the ribbon interface, and I'm sure some people like it. I still like reading text. You know, call me old-fashioned, but when we look at multi-axis, they've broken it down now, you'll see, into pattern and application. So pattern being you choose the cut pattern essentially that you want the tool to follow. Application is more application specific. You can try the rotary cuts. This may work depending on the machine configuration, but curved 5-axis will always work. So with curved 5-axis, it is essentially 5-axis contour. We tell it a chain of geometry that we want to cut, and the tool is then going to cut that geometry, and we have control over the tool axis. So how are we going to tilt the tool in Mastercam? And eventually that tilting vector gets converted by the post processor into rotation. So multi-axis can for sure drive this, but there are some non-multi-axis paths that will also cut this shape. And the limitation with using the multi-axis is that you have to have the multi-axis license. So we're going to look at a couple of different options. When I first looked at this part, where did this go? Okay, here's how it first came in. I always get... So my recording software uses the same toggle button as this guy right here, show axes. So I always forget to do that and end up pausing the video by mistake. Luckily, I caught it and I restarted the video, so we're good there. But when we first look at this, you know, here's the orientation. If we're putting this on a horizontal machine, then this would be our starting point. And the reason that's true is that the front plane is the default 0 plane for horizontal machining with the generic Fanuc 4-axis posts. So a lot of people don't realize that the generic Fanuc posts will support 4-axis rotation and 4-axis multi-axis motion out of the box. So to do the multi-axis path, you still need the multi-axis license, but we can still drive that with the regular 4-axis post. There is logic that exists in that post. Yeah, go navigate to that. I'm just going to pick the generic Haas 4x mil post. I'm pretty sure that the one we've got over here is one that I've been modifying. That one's, you know what? We'll show it with, we'll do MP Master. This should be a fresh copy of MP Master here. Because it basically uses the exact same logic. So when we talk about reading data from the machine definition, from the control definition, and from the operations, that data is stored in numeric parameters. In the pprep post block, which gets called before the NCI file is even opened, we go through and we read the machine definition. Read machine entity number is a helper variable that tells MP which set of parameters to go read. Typically, we're going to set it during processing to the number of our current axis combination so that we only get the entities that are in our axis combo. During processing in pprep, we read all of the machine def. So that's what this tells it. Go out and read the machine definition. And this is the command variable that actually launches it. So when we hit RDMD, we're actually going to process all of the machine definition parameters. Machine definition parameters process through pmachine info. So there's this, oh yeah, where do you get this? This is an in-house post. This logic, though, that's in here is the same that's in the generic Fanuc 4x mil and all of those other generic 4-axis posts. If we go look in a generic CNC software post, you know, I'll pull up the Fadal just because all of these generic 4-axis posts are based on the, you know what, I'll pull up MP Fan because MP Fan's got this. Ooh, MP Fan might be the one that doesn't. I'm getting ahead of myself. I'll call up the generic Fadal format 1. And if we search for RDMD, it's basically got the same command structure. It sets read machine ent number to 0, go get all the machine definition parameters, and it calls RDMD. And that makes calls to P machine info. So what P machine info does is it sets the machine definition table. So there's a line of code in here that says run this parameter table if the number is between 17,000 and 18,000. And up here in our machine definition parameter table 17,000, we capture data from the machine definition. So when you look in your machine definition, and you look at one of the rotary axes, each one of these settings, counterclockwise, clockwise, axis supports continuous positioning, or axis positions to fixed angles only. So is it an index or is it continuous? And of these three options, which one is turned on? This data is output as numeric parameter values. You can look in the documentation and you can, there are pictures that are labeled from the machine definition that tell you which number relates to which specific variable. We capture specific parameter numbers and we load it into a user-defined variable. So we've created these variables that hold, for example, the axis label, the rotary label, the rotary 0 degree position, the rotary direction, whether or not the machine supports index or continuous motion, and several others. So we capture this data. In addition to capturing the variable values, we have a specific routine in here that looks for more than one rotary axis. When we start capturing data in these particular parameter numbers, each one of these is going to relate to the specific component type that we are capturing it from. For a rotary component, it's 19958. So if the parameter code is 19958, that tells MP that there is a rotary axis present. And the way that this works is that rot ax count starts at 0. So we read the parameter number, then we run this right here. Component type equals, and we read the 19958 string parameter, and if component type equals 5, then we run this logic here. So 5 says 19958, that particular component is a rotary component. This line of code increments the rotary axis count by 1. So when we first run this on a 4-axis post, this logic should only execute one time, because what it does is it sets rot ax count. So rot ax count equals rot ax count plus 1. The first time we run it, 0 equals 0 plus 1, rot ax count gets set to 1. Then, as we're parsing the data, as we're reading the machine definition, if parameter count is 9958 again, and it will be for several different components, if component type is equal to 5, we're in trouble, because then rot ax count being equal to 1 will now equal the current value, which is 1, plus 1. And then we hit this if statement. If rot ax count equals 2, rot ax error equals rot axis error plus 1. This is what signals to the post that we've detected more than one rotary axis, and the post will shut down. This post only supports a single rotary axis component inside your axis combination. So that's an important distinction to make, because you can have an axis combination with a setup with a rotary axis on the X, or you could have an axis combination with your rotary on Y, because maybe you have a machine where you sometimes rotate the fourth axis on the machine table. That's perfectly valid. But what you can't have is an axis combination that has two rotary components in it, because this will shut it down. Now, there is another bit of logic here that determines if you are running a horizontal or a vertical. So this little bit of logic is what sets the VMC switch. So if parameter code equals 17392 and axis label equals 3, which tells it that it's a Z axis component, it says Z direction equals rpar S parameter 1. So we're setting the value of Z direction using 17392. And the potential values that it could be is a 1, 2, or 3. You notice that 3 is plus Z. Or it can be 7, 8, or 9. And if it's 9, it's negative Z. If it's 8, it's negative Y. And if it's 7, it's negative X. So if Z direction does not equal 3 and Z direction does not equal 9, VMC equals 0, which means that it's a horizontal machine. So we're looking for, in our Z-axis here, see, we're looking to see if it's set to 3 or if it's set to 9. And if it is, if the spindle is located in Z according to the world coordinate system, then it's a vertical machine. In our case, with our HMC Z-axis, the positive axis direction is plus Y, and actually it should be negative Y. Why? Because positive Z is going along the back of the machine. The number should grow as you retract, and it should get smaller as you go towards 0, with the caveat being that this is the part 0, not the machine 0. So that Z-axis direction does get read here, and again, if it's not vertical, VMC switch gets set to 0. Else, meaning Z direction is either 3 or 9, VMC gets set to 1. So this logic is the same whether the post is MP master or the generic Fanuc format 1 or the generic Fanuc 4x mil post. Basically any of the 4-axis post processors that you could potentially get from CNC software as a generic post, all their logic is based on this. So that's what's in the post, and basically we use this machine definition and also our style of programming. So when we program for the 4-axis horizontal, we should be programming with the part vertical along the WCSZ, but we should be using the front tool and construction plane to give us B0 as our initial position. And we need to use planes that are a rotation of the front view. So when we look at planes, here's our top plane, XYZ, which stays our WCS. So the WCS is top, but the front plane is our 0 rotation plane. I'm going to delete all the unused planes. One of the things that this gives us by default when we use the out-of-the-box horizontal machine, front plane will automatically give us B0. Right side should automatically give us B90, and by default, if we don't change any of the existing settings, it will also give us G55. Back will give us B180, and it will give us G56, and left side will give us B270, and it will give us G57. That is the way that the posts have been set up for a long, long time, and it was set up to make programming for a horizontal machine easy back in, the late 80s, early 90s. So this convention is kind of a holdover. But one thing you will see, whether I pick front, look at the Y positive direction. See how Y positive points straight up? If I pick the right side, Y positive still points straight up. If I pick the left side, Y positive points straight up. And if I pick back, same story. What you have to have is you have to have a single vector that remains constant when you are programming for a 4-axis rotary. It doesn't matter if the 4-axis rotary is vertical, rotating on X, vertical, rotating on Y, or horizontal, rotating on Y. One of those axes has to remain pointed the same direction. And if you look at bottom, Z-axis is flipped, but so is Y. And this is a problem that happens when we start programming for a 4th-axis vertical machine. Because what that means is that when we start with top and we're rotating about X, I can now program with front and X stays pointed to the right. But when I pick bottom, X positive flips. So I can't use bottom for A180 with the stock post. It gives me an error. And the same thing happens with back. I can't use this for A270 if I'm programming a vertical machine. It also gives me an error. So what I recommend anyway is that when you're programming a horizontal machine like this, I usually take my front plane and I make a copy of it. Because it's a copy, you can rename it. And then I'll manually assign a work offset to it. Oop. Having a work offset of -1 means that every time your plane changes, Mastercam is going to auto-magically calculate a new rotation and a new work offset for you. Setting it to a number means that no matter what, it'll never change on you. So now if we take B0 and we do a dynamic plane, call this one B90. I thought 90. So we're going to leave Y position the same. We're going to rotate Z over facing out to the right, and we'll call it B90. Say OK. We get our B90. Oh, and I need to set my offset. Now, I could go around and I could create my B180 and my B270. We don't need to do that for this particular shape that we're trying to cut. So I'll just leave the talk about setup there for the moment. When I looked at this part, we've already got some curves created from the top and bottom of the wall. And so one of the things I did when I first looked at this part file was to do this. Took the original curves here, and I went to Home and clicked on the endpoint display. And so what we can see right away is that when we generated curves on that shape, the start and stop points, the end points of those curves are actually aligned with X plus. What that means is that that's where the start and stop point of our toolpath is going to be. And so since we have to program in front, that won't work for us. So what I ended up doing, press enter to continue. Machine design, file new. So what I ended up doing was I ended up rotating the file. On used. Okay. Okay. Save that. Home endpoints. So here, when we look from the top view, I've rotated the part 90 degrees, and that means the start and stop position of those tracks is now aligned with my spindle, since I'm using a horizontal machine. So this is going to be B0, which means that if I were to cut this, I can start at B0 and I can rotate positive or negative 360 degrees and come back around to the same end. Now, I could let it rotate just 90 degrees to start its path if there was some benefit to doing so, but why not have it go 0 to 360 if you can get it to do that? You know, it's one of those personal preference things. Like, I like lining up my parts as they sit in the real world so that I know where I'm starting from. And, you know, what if the machine only has 0 to 360? I've seen machines where when you cross over 360, it unwinds 180 degrees to get back to 0. It can be dangerous on a 4-axis machine. So you really need to know. I mean, I get the feeling, Jeremy, sometimes you get spoiled with some of the good machines that you get to run. A lot of them have newer controls. So, you know, when you're running an older machine from the 1980s, sometimes you don't get those luxuries. So that's why I do some of this stuff, and to get people to understand. You know, you start cutting, you're like, well, why does it go to 90? Because the alignment of where the cut starts is 90 degrees out of position. Well, okay. So then you ask, why not just, you know, why not let it rotate? Because sometimes the machines don't like that. Sometimes it doesn't matter. And in that case, why not? But again, I like rotating things to where the start point of my geometry matches the 0 position on the machine. You know, what if we do this thing on a 5-axis machine? I mean, yeah, you could let it start at 90, but what if there's something hanging off on one side? I mean, what if you wanted to cut it where it only span, you know, 60 degrees at a time? Do you know how to do that? By breaking up your geometry and operations and doing, you know, one at a time. Sometimes, you know, you have to make sacrifices for what you got, and I know you know about that. So what I looked at, I took the original curves and I used wireframe, create point, node points. And I do this a lot to see how the splines are built. And if you look in isometric, I've got the points on, so this is the lower part of the channel, which is the blue dots, the blue points and the red points. So I created them and then created them in different colors using the create point on the node points command. And when I look at it in the top view, at least on the bottom channel, something beautiful happens. All the points are in alignment top to bottom. The reason I bring that up is because we're not driving lines and arcs. The geometry that we've got to work with is created based on, whatever geometry was given to us. Right now, when we look at the track curves, that's spline data. And a spline is a mathematical curve that flows between control points and uses knot vectors to determine how much those control points pull the geometry or push the geometry. And what we end up with is a smooth curve, but when we are trying to do a 5-axis path and we're trying to synchronize those curves together, we need to be able to tell the tool how to track along the curvature. And one of the methods we can use is to synchronize the curve. One of the options on sync is to sync by node points. And we could probably get some good syncing based on the inner curves. But when we look up at the top and we look at the outer curves here, you can see that those spline points are not really lined up top to bottom. Now, when we're cutting this on a 4-axis machine, we really don't need to worry about the outside curves of this track because we've only got one axis to rotate. And so what that really leads me to is thinking axis substitution would probably be a great path for this. And somewhere around here. So, what I did was to take the splines on the inside and I used transform roll, which actually has an unroll command built into it, to unwrap this geometry and make it flat. So if we look from the top view, this unrolled geometry is all lying along the x-axis. And this is basically what it originally looked like. So I took those curves and I unwrapped them. Let's get rid of that. Ooh. Okay. Get back to that. Let's see here. Okay. So in order to unwrap the chains, we need to know what the diameter is that this is wrapped on. So I was able to make some slices of the geometry. Yeah, we could do analyze dynamic. We could click the solid face, and that would give us the radius. But the other thing that you'll see about this, when I started analyzing some of the geometry, you know, this is modeled where things are just slightly off. So in a case like this where, 8.499999, we can pretty safely assume that they meant to do it at 8.5. There could be some scaling issues. It could have been a metric part or something like that. So it's a diameter of 8.5, a radius of 4.25 at the bottom of the track. And that's what we're concerned with getting anyway, is the bottom geometry. Can actually get rid of those two top pieces, don't really need them. So, green's good enough. X form, roll. Grab both of those as chains. And now we use the option here to unroll. We're going to unroll about the y-axis. I do have my plane set, my construction plane set to front, and this is important. We have to unroll about the front. And you can choose your direction, clockwise or counterclockwise. Give it the diameter, 8.5, and this is what we get. So whether we choose clockwise or counterclockwise, it will basically choose which way it unwraps it, and that may be important depending on on which rotary direction you have. You're going to have to do some testing. But yeah, unroll does have to be about a constant radius, which these are. So I did do some testing on it, and this is a flat flat floor radially. What if they aren't? If they aren't, then you're going to have to do it 5-axis. You're not going to be able to do it. So when you use the axis substitution toolpath, what you're doing is taking one of the linear dimensions and you're substituting it for an angle of rotation. So by default, you have to be on centerline with your tool, and you have to be at a constant radius. Now, you can put a taper. The wrap has to be around a radius. On the X form roll, you can do things like take this and tilt it so that it has a constant taper on I guess the Y across it, and that will change the Z positioning a little bit for infeed, but I'll show you another way of dealing with that. So one of the things you can also do, you set the accuracy down here for how much it's stepped on accuracy to 0.1. Oh, come on. Alright, you know what we're going to do? We're going to save. Come on. Come on, Mastercam. Alright. We were able to successfully quit before it crashed. That's awesome. Alright. You know what we're going to do too? We're going to do a quick down the video, and we're going to start a new one.